Okay, so in this video we're going to talk about linear inequalities. But before we talk about linear inequalities, let's just talk about what inequality is, or what the greater than or lesser than signs are. So inequalities might look like this. Okay? In between the two numbers in this particular example, we don't put an equal sign because 2 does not equal 5. Okay? This symbol that we put in between the 2 and the 5 is the symbol for lesser than. Okay, so 2 is lesser than 5. What lesser than means is that 2 falls to the left of 5 on the number line. Okay? That's all that lesser than means. The number that's lesser than the other number falls to the left of that number on the number line. Okay. I think most of you know that. One thing I do want to point out is that when things are negative, things get a little bit strange. If you multiply each of these by -1 and don't change this, okay, is that true? Is -2 less than -5? Well, the answer is no. -2 is actually greater than -5, okay? Or another way to write that would be, so -2 is greater than -5. Or another way to write that would be -5 is less than -2. Remember, less than means it falls to the left of the other numbers. And -5 does fall to the left of -2. So, the rule, or what we take out of that, is that when you multiply or divide by a negative number, remember, these inequalities are basically the same as equations. You can do things to either side of the inequality, as long as you do it to both sides. But different than an equation, if you multiply or divide by a negative number to both sides, it makes the inequality flip. A lesser than becomes a greater than becomes a lesser than. So, with that in mind, let's do a few problems. Alright, let's just do an easy one first. Or like one with not that much going on in it. I won't say easy. So 2x is less than 4. We have to solve for what x is. Now, in an equation, if I said 2x equals 4, there'd be one answer. X would equal 2. Well, this isn't an equation, it's inequality. Okay, there's going to be more than one answer. But you can do them the same as an equation. You just have to remember that if you ever divide or multiply by a negative number, you have to flip the direction or change the direction of the inequality. So we don't have to do that in this problem. X is being attached to a 2, or 2 is being attached to an x. That means we're multiplying x by 2. So to undo that, we have to divide by 2. Well, we have to divide by +2, which is not a negative number. So we don't have to worry about flipping anything. So our answer is just x is less than 2. Now, you can check your answer. You can check your answer by just picking numbers that work, basically. In other words, my answer is x is less than 2. So that means, oh, if x is less than 2, 0 must work. So you go back to the original equation, or inequality, I mean, and you plug in 0. And you get 0 is less than 4. You ask yourself, is that true? Yes, it's true. So 0 does work. Try -3. Since x can be any number less than 2, -3 should work. I'll just write down the original problem. -6 is less than 4. That works. Try one that's bigger. Supposedly our answer is every number less than 2. Well, let's try a number bigger. Let's try 10. 20 is less than 4. No, that does not work. That leads me to believe that the answer is x is less than 2. In other words, the answer to that inequality is any number less than 2 will work, or satisfies the condition. Let's do one that has a little bit more work in it. -2x minus 2 is less than 10. How about we do less than or equal to? That's what that symbol means. When you put a line under either the lesser than or greater than symbol, it just means it's also equal to. So let's do this problem. Well, one of my favorite things to do, well, I'm not going to show you right now. I'll show you after I do it this way. You can treat these problems, like I said, just like an equation. You can add something to both sides. You can subtract something from both sides. You can multiply by a positive number to both sides. You can divide by a positive number to both sides. You can multiply and divide by a negative number to both sides, but you have to remember to change the direction of the symbol. So in other words, I can add 2 to both sides, and I'm left with -2x is less than or equal to 12. Now I'm going to divide by -2 because I want x by itself. I'm going to show you that in a whole different step. So I'm going to divide by -2, but remember, when you do that, you have to flip the direction. So we get x is greater than or equal to -6. So x is greater than or equal to -6. That means x could be 0, right? 0 is greater than or equal to -6. So I'm going to just check my answer by plugging in some numbers. So 0 should work. 0 minus 2 is less than or equal to 10. -2 is less than or equal to 10. So it looks good. You don't have to check, obviously you don't have to check every answer because there's an infinite amount of answers. You can't check every answer. But it's good to check one. Since this is greater than or equal to -6, that means -6 should also work. Let's see if it does. So -2 times -6 is positive 12. You get 10 is less than or equal to 10. That's true, because 10 is equal to 10. It's not less than 10, but it is equal to 10. Okay, so I'm going to show you another way to solve these. It makes it so not that it's hard to remember to flip the direction of the inequality, but this other way I'm going to show you makes it so you don't have to remember that. Most people just prefer to do it this way, where if they ever have to divide or multiply by a negative number, they remember to flip the direction. But some people don't like to do that. So I'm going to show you another way to do it. I'm going to just try to do the same problem, but I'm going to do it a different way. They don't talk about it in the book, but this is called the critical value method. Okay. Now, in the critical value method, there's two things you're looking for to get critical values. The first thing you look for is anything that would make the inequality undefined, but there's nothing that we're going to talk about in any of the problems that we do that are ever going to make the inequality undefined. So the other thing that you look for is any value of x that would answer or be a solution to the equation if you change the inequality to an equation. So that's what we're going to do. We're going to change this to an equation. And all you do is you literally just replace the inequality with an equal sign. So now it's an equation. So now we're going to solve this equation. Now when you have an equation, it doesn't matter if you divide or multiply by a negative number. If this is really equal to that, then multiplying or dividing by a negative number to both sides, each side will still be equal. So I'm going to add 2 to each side, then divide by negative 2. You get x equals negative 6. Okay, this is called our critical value. What you're going to do then is you're going to draw a number line that has negative 6 on it somewhere. Then you're going to just put a few other numbers on there. What you're going to do next is you're going to test this number here, which was our critical value, and then you're going to test the number up here, anywhere up here, and then a number down here. And what you test it in is you test it in the original inequality. So I'm going to test negative 6. I'll just put x. I like to write the original thing first. So you get 10 is less than or equal to 10. Is that true or false? It's true. So you write t above it. That means it works. Okay. Then you're going to test a point that's greater than negative 6. Well, one of the easiest points to test is when x is 0. So you could test like negative 5, but you might as well just test 0. Okay. So you're going to plug 0 in. I always do that. I want to actually show the original problem. You don't have to, but I like to. So I'm plugging in 0. You get 0 minus 2 is less than or equal to 10. Negative 2 is less than or equal to 10. Is that true or false? It's true. So that means everything up here is true. Doesn't mean just from 0 on is true. It means everything. If you test any point from here to infinity and it works, that means everything to the right of negative 6 works. Okay. Then you're going to test a number down here. So I'll test negative 7. You get 12 is less than or equal to 10. That's not true. Okay, so that means negative 6 works and anything above negative 6. So the answer is x is greater than or equal to -6. Okay, so when you do it that way, you don't have to worry about flipping the direction of the inequality. So some people like the critical value method better than just doing it in a normal fashion where you just can add or subtract numbers from both sides, multiply and divide by a number on both sides. Just remembering that if you multiply or divide by a negative number, you have to change the direction of the inequality. I like doing it this way, using the critical value method, but I usually check my answers anyway at the end, which this, while you're doing it, is kind of like a check to begin with, so I think that's why I like it.